This is Solving Quadratic Equations Using the Quadratic Formula, Part 2. So today we're going to talk about the discriminant. When we say the discriminant, we're talking about the b squared minus 4ac part of your quadratic formula. So this piece right here in red. When we figure out the value of the discriminant, it tells us some important things about our quadratic equation. If the discriminant's value is greater than 0, your equation will have two real solutions, which means on a graph it has two x-intercepts. If the value of your discriminant is exactly 0, you're going to have one real solution. And on the graph of your quadratic equation, you'll have one x-intercept. If the value of your discriminant is less than 0, you will have no real solutions, no x-intercepts on the graph of that quadratic equation. So let's determine the number of real solutions for each quadratic equation here by finding just the value of the discriminant. So in this quadratic equation, a is equal to 1, the b value is 8, and our c value is -3. And for the discriminant, we're just doing the b squared minus 4ac part of our quadratic formula. So we're basically doing 8 squared minus 4 times 1 times -3, which gives us 64 plus 12. So our final answer here is going to be 76. Since 76 is greater than 0, this particular quadratic will have two real solutions. In this quadratic, we need to do a little bit of switching around to get our a, b, and c value. So I moved the 6x over to the other side. My a value is 9, my b value is -6, and my c value is 1. So I'm just doing the discriminant, so b squared would be -6 squared minus 4 times a, which is 9, and c, which is 1. So I'm going to get positive 36 minus 36, a value of 0. So in this case, we'll have one real solution for this quadratic equation. Now, when we're finding the number of solutions, those solutions are equivalent to an x-intercept on the graph. So when we're being asked to find the number of x-intercepts on the graph, we're really finding how many solutions there are, how many times the graph of that quadratic equation will pass through the x-axis. So we can still use the discriminant to also find the number of x-intercepts. So when I'm looking at this quadratic, I'm going to set it equal to 0 and find my a, b, and c values. I want to set it equal to 0 because anytime we have an x-intercept, we get a number comma 0, an output of 0, a y value of 0. So here a is equal to 2, our b value is 3, and our c value is 9. So we're doing b squared minus 4 times a times c. So here I get 9 minus 72, which I know is going to be a negative number, -63. When I get a negative number, I can't do the square root of a negative. I'm going to have no x-intercepts here, no real solutions for this quadratic equation.